Welcome to ClickMyProject.com.
Now we are going to discuss about the product single image de-hazing using globally guided image filtering. Now we are going to discuss about the abstract for the process. Local edge preserving smoothing techniques are such a guided image filtering, that is the GIF, and the weighted guided filtering, that is the WGIF, could not preserve the fine structure. In this paper, a new globally guided filtering, that is the G-GIF, is introduced to overcome the problem. The G-GIF is composed of a global structure transform filter and then the global edge preserving smoothing filter. The proposed filter is applied to study the single image de-hazing removal process. Hence, the experimental result shows that the fine structure of the de-hazed image is indeed preserved the better by the proposed G-GIF, that is the global guided filter, and then the de-hazed images by the proposed G-GIF are sharpened than those of de-hazed image by the existing of the G-GIF. Now we are going to discuss about the flow diagram for the process. Hence, this is the overall flow structure for the process. At first, the input image is taken from the dataset. Dataset is the folder which consists of the several input images. Hence, we get the input image from the dataset. After that, the pre-processing is done. In this pre-processing step, we done the two steps. The first step is the channel separation, then the second step is the contrast enhancement. The first step consists of the channel separation, which separates the channels like RGB. RGB represents the red, green, blue. After the channel separation, the initial contrast enhancement is done to enhance the image slightly. After that, the haze detection is carried out. In this haze detection process, two steps will be carried out. The first step will be the threshold calculation, and then the second step will consist of the G-GIF. In this threshold calculation, we just calculate the threshold of the whole image. After calculating the threshold, the region is segmented as per the threshold limit. After that, the G-GIF is applied for the smoothing purpose. At last, the haze removal is done by using the smoothing like GIF and STF. Hence, these are the two techniques to done the smoothing of the images. Hence, this will provide the appropriate results for the smoothing. After the haze removal, the haze removed image is the output, which consists of the enhanced image. After that, the performance is estimated by using the performance estimation module. Hence, the performance of the time will be calculated. Now we are going to discuss about the initial running procedure of the process. At first, open the MATLAB 2015 and change the current directory. If you want to execute the code means, just right click in the main file.m and select the option run. Now you can see the folder dataset. Now open the folder dataset. You can see the some of the dataset images presented here. Select any one image from the dataset. After the selection, the process will be done automatically. At last, the final de-hazed image is generated. I will discuss the results one by one. Now the figure 1 shows the input image which I have selected from the dataset. After the selection of the input image, the figure 2 will be processed for the G-GIF. Hence, the figure 2 results will be shown as an white color because the data type will be changed, but the pixel limits will be vary in the range of 0 to 255. Now the simplified dark channel is shown in the figure 3, hence the simplified result is in the grayscale format. The dark channel of the grayscale represents the original pixels, and then the bright regions represents the hazy pixels. Now in this figure you can clearly see the hazy regions are in the brighter regions, otherwise the dark regions will consist of the original pixels. Now the structure transformed is shown here. Now the structure transform result is shown as an two layer, the first layer and then the second layer. The first layer consists of the some noisy regions, and then the second region is fully smoothened by using the structure transform filter. After the structure transform filter is applied to the image, the positioning of the atmospheric light is carried out. Atmospheric light is nothing but the unwanted regions added in the original pixels, that is the atmospheric light. Hence we have to detect those regions and then we have to eliminate so that the atmospheric light is detected. At last, the sixth figure indicates the input image as well as the de-hazed image. The de-hazed image is the image which is consist of the haze free image. Now you can clearly see the regions which consist of the hazy in the figure 1 will be eliminated in the output region.
Thanks for watching this video.